Hello everyone, today we are going to talk about homework 11 question 1. It is given that the stochastic process xt is a real Wallace stationary with autocorrelation Rxx tau and power spectral density Sxx omega. Shows that question 1, question A, Rxx tau is real and even. And because xt is a real Wallace stationary, so that Rxx tau equals to Rxx t plus tau, comma t, and it equals to expectation of xt plus tau multiply xt. Also, it equals to, if we change the sequence, we know it equals to expectation of xt multiply xt plus tau. Therefore, it also equals to Rxx of t, comma t plus tau. And it also, so if we reduce tau at both sides, we get that it equals to Rxx minus tau. Therefore, Rxx tau is even. And question B wants us to prove that Sxx omega is even and non-negative. We know that Sxx omega equals to integral from minus infinity to infinity Rxx tau multiply e to the power of minus j omega tau, and it equals to, we can expand e to the power of minus j omega tau to cosine omega tau minus j sine omega tau, and we can plug in to the integral equation, and we get this equation. The second part, we know that sine omega is an odd function. So if it integral from minus infinity to infinity, it equals to 0. And we know that cosine omega tau is even function. So the above equation equals to 2 multiply integral from 0 to infinity Rxx tau multiply cosine omega tau, and it because the cosine omega tau is an even function, so it also equals to cosine minus omega tau. So it equals to xx of minus omega. So if we want to prove that xx omega is non-negative, we can, using a following system, that xt is a Wallace stationary, and it processed by HW. Suppose that HW is an ideal band path system, and HW equals to 1 if the omega is between omega 1 and omega 2, and equals to 0 if in the other part. So that expectation of absolute value of yt squared equals to this function. And we know that if xx omega is non-negative in any integral, so that if we want to make sure that satisfy this equation, we have to make sure that Sxx is larger than or equal to 0 everywhere. Therefore, we show that Sxx omega is even and non-negative.